sorry to interrupt, but there is things I believe in determinism, and I want determinism. But it looks like there is indeterminism. I was planning to make it until 6, more or less. If people want it, maybe not more than 6. But now I learned that because workers should go out, that they want us out at 5:20. So I'm really sorry about this. And I know that one person signed up for open discussion. And so probably we'll have to thank Jen and go with you, and we'll have just about 12 minutes for open discussion. Bureaucracy.
Chair goes on. Okay, so I'm not quite sure what to say or what to introduce. Shall I? Well, we have this open discussion. And the question posed is the many worlds interpretation explains well the evolution of the world we experience, but does not single it out from numerous parallel worlds. How important is this weakness? Note the presumption that it's a weakness at all. The floor is yours.
Okay, so I wanted to make a small point about this, and that is that the word numerous here doesn't really capture the complexity of the many worlds interpretation. So usually we think that, many worlds, maybe there are hundreds or thousands, maybe there are zillions of worlds, so maybe one with some dozens of zeros after it. But in fact, if we think of any experiment that say in Anton Zeiliger's group, they want to measure something, they measure thousands and thousands of photons, and the world is split thousands of times. So the number of different worlds, different copies of us, are actually Googles. There are more than 10 to the 100. And this strikes me as a number that has only mathematical significance. In all of physics that I can think of, the numbers that we use, even when we count the stars in the universe or whatever, we always make do with zillions. We don't go all the way up to Googles. When it's Googles, it's, I think that's mathematics, it's not physics.
How you can get this Google?
If you just assume that they have measured a few hundred photons, and each one's...
They measure currents. The single photon detector, they don't have many single... The splitting of a world only happens when you have macroscopic multiplication. If you have many photons and you don't know exact number, there is no too much splitting.
But even
you have to really. I think it's not clear how splitting what happened 200 years ago before quantum devices. Now there are quantum devices, Geiger counters, other things. So we have splittings, but no 10 to the 100. You need
no. Just if someone clicks on your web page, and someone else clicks, and after you have. The first time it splits, say, in 2, and then it splits maybe in 6, and so on. And after a few hundred clicks, the number of parallel worlds will be Googles. A few hundred clicks, not more than that. A few hundred people clicking on your web page.
Thank you for that, but no, I think you've got to stay. You said something very provocative. I want to just temporarily channel. Right. I can temporarily channel Nikolai and say, how many points of space are there? How many moments in time are there? So I think the idea that these numbers are unphysical is not so true.
So if you count space in, you count in Planck lengths, not a mathematical infinitesimal, but a physical smallest distance we can think of, then the number of points in the observable universe is 10 to several hundreds. It's not 10 to thousands and 10 to hundreds of thousands. Right. So this connects, you know. So the first time I thought about this argument is when I heard a podcast by Sean Carroll talking about infinities in the multiverse and the different multiverses that there are, you know, the cosmological multiverse and so on, and talking about Boltzmann brains and so on. So if the universe really continues forever, infinity, mathematical infinity, in all directions or in the temporal direction to very long times, then you would expect Boltzmann brains. But that's not physics, that's mathematics.
Just, first, unfortunately, there is another thing. Also, the driver was only for 5:20. So then maybe we have 3 minutes, David, and so we'll have to finish now. But I think it's still 6 or again.
Okay.
Well, I mean, there was let's grant this is correct. It sounds correct. I'm just not quite sure what follows from it. I mean, in the late 19th century, I can imagine someone responding to the atomic hypothesis by saying, well, if this is right, then that means there's going to be something like 10 to the power of 50 atoms in the universe. 10 to the 50, that's not physics. Physics is thousands, millions, maybe billions, but not 10 to the 50.
It's not a strong
Thank you, David.
So yeah, just real quick. I mean, one nice thing about the computer networking explanation of quantum mechanics is that it does provide a mechanism for singling out some versions of the world as being actualized, right? So if you think about a simple game DVD of the World of Warcraft, right? There is a ridiculous amount of possible states that players can adopt in the video game world that correspond, and there are certain probabilities, right, that players will adopt some of those states. But if you've got 10 million players playing the World of Warcraft, as a matter of fact, at any given point in time, there will only be 10 million of those massively more possible states actualized or experienced by observers. So there is a mechanism for singling out which of the experienced worlds are actual or experienced by an observer, as opposed to those that don't have any observers at all, that don't have any sentient creatures or human beings experiencing them. They're in the probability space, and they could be experienced, but as a matter of fact, they're not. And I think that's another thing that speaks in favor of that particular model.
On the other hand, it might be a nice feature that there are many worlds and that we actually only see a part of it. That, to me, is actually a beauty of the many worlds idea.